Today's lesson is called Geometric Sequences. So to start, I would like you to try the opening exercise. It says the first four terms of an arithmetic sequence are 9, 14, 19, 24, and then you can see the ellipsis showing that pattern is going to continue. I'd like you to find the value of a sub 20 without listing out all 20 terms. So that means you should be using some type of formula. So at this time, please pause the video, try the opening exercise, and then resume the video to go over the answers. Okay, now that you had a chance to try on your own, here's the answer to the opening exercise. Looking at the numbers, I'm looking for a pattern. I see a +5 pattern. So that makes this arithmetic sequence. So I want to follow the format of the formula that's given on our reference sheet. A sub n equals a sub 1 plus d times n minus 1. Where remember, a sub 1 is the first term, that's going to get replaced, and d is the common difference, that's going to get replaced. So looking at my sequence, 9 is the first term, and the common difference is 5. So you can see I put 9 in a sub 1's spot, and 5 in the common difference spot. That then is giving me the formula that I can use to jump to any term in the sequence. So I'm going to find a sub 20, which means 20 is going in for n. 20 minus 1 is 19. 5 times 19 is 95. When I add that to 9, I get 104. So the 20th term of this arithmetic sequence is 104. I can jump to it quickly by writing the formula and using the formula to find the 20th term. So now let's look at another type of sequence, which is called geometric. Geometric sequences is what we're going to define first. A geometric sequence is a sequence of numbers in which the ratio, which is represented by r, stays constant. That R ratio that I'm talking about is called a common ratio, and it is found by dividing each term by its previous term. So an arithmetic sequence has a common difference. A geometric sequence has a common ratio, which is why we've separated the sequence into our newest chapter. So just like we did for arithmetic sequences, we're going to go through and take a look at all the questions that may be asked of us when it comes to a geometric sequence. And the first one would be whether or not this even is really a geometric sequence. So the directions here say determine whether the sequences are geometric. If yes, identify the common ratio. So we're looking for a multiplying pattern here. So in number 1, I would want to take 45 and put it over the term that came before it. If I do that, I get 1/3. I would want to make sure that that stays constant. So 15 over 45 would also equal 1/3. And then if I did 5 over 15, I still would get 1/3. So is this geometric? Yes. And it said, if yes, identify the common ratio. So our ratio would be 1/3. I multiply each term by 1/3 through the sequence. In number 2, we have x, 2x squared, 4x cubed, and so on. So I want to know if this is geometric. So I'm going to take the term and put it over the one that came before. 2x squared over x turns into 2x. So then we would do 4x cubed over 2x squared. 4 divided by 2 is 2. X to the third divided by x squared would be x. So far, we have a constant ratio. When I take 8x to the 6th and put it over 4x cubed, 8 divided by 4 is 2. X to the 6th divided by x to the third, we subtract our exponents. That would be x to the third. So I do not have a common ratio. It broke up between the third and fourth terms. So that's why it's so important to check not just the first combination. Something could hold true for a while and then all of a sudden fall apart. So this is not a geometric sequence. There's not a common ratio. Looking at number 3, I would take 18 and put it over 6, the term that came before it. 18 divided by 6 is 3. Then I would take 24 and put it over the term that came before it, which is 18. And when I do 24 and 18, I want to simplify that, and I get 4/3. 6 goes into both of those. And 4/3 is not equal to 3. This is not a common ratio, so this is not a geometric sequence. In number 4, we would put negative 14 over the term that came before it, which is 7. That would be negative 2. 28 over negative 14 is negative 2. Negative 56 over 28 is negative 2. So there is a common ratio. It's the same every single time. So yes, this is geometric. And r is equal to negative 2. So when you're trying to identify a geometric sequence, you're looking for a multiplying pattern. You want a common ratio. Take the term and put it over the one that came before it to determine that. Okay, next. We should also be able to continue the pattern. So continuing geometric sequences. It says, given the geometric sequence, find the next 3 terms. So I've got to figure out what's going on. So I already know it's geometric, so I know there's a common ratio. So I just have to find it. I find the common ratio by taking a term, negative 25, and putting it over the term that came before it, negative 5. So negative 25 over 5 would be 5. My common ratio is 5. So that tells me I'm going to be multiplying by 5 to get my next numbers. So I would do negative 125 times 5, which is negative 625. I would then take negative 625 and multiply it by 5, which is negative 3,125. And then I would take that number and times by 5 and get negative 15,625. In number 6, we've got 8, 4, 2. So to figure out the common ratio, I will take a term like 4 and put it over what came before it, 8, which gives me 1/2. My common ratio here is 1/2, so that's what I'm going to multiply by. So 2 times 1/2 would be 1. 1 times 1/2 would be 1/2. And 1/2 times 1/2 would be 1/4. So once you know the common ratio, you can continue the pattern by multiplying by that common ratio. Moving on, just like we had for arithmetic, we have an explicit formula that we can use to determine any sequence term. So the geometric sequence formula, you see here, it is on the formula sheet. The nth term of a geometric sequence can be found by using the following formula. A sub n equals a sub 1 times the common ratio to the n minus 1 in the exponent position. So let's go over what this really means. A sub n is the value of the nth term in the sequence. This would be considered the output, or in other words, a part of the range. A sub 1, just like it was before in arithmetic, is the value of the first term. When you see the letter n, n is the term's location in the sequence. So this would be the input or a part of the domain. Now remember here, we're using your counting numbers. So we're starting with 1, 2, 3, 4, and so on. And then as we discussed before, R is going to be the common ratio. And it comes from doing any term. So we'll say a sub 2 over the one that came before it, a sub 1. So we're going to use that formula to now answer some questions and possibly even write the formula ourselves. So in the next set of examples, number 7 and number 8, the directions are, given the formula for the nth term, find a sub 10. So in number 7, we already have the formula. We want to find a sub 10, so I'm going to replace the little n subscript with a 10, and that means I'm going to substitute 10 into the formula when I see the letter n. So that would be 10 minus 1. So that means a sub 10 is equal to 3 times 3 to the 9th power. Now you can type that entire thing into your calculator. If you're going to show the steps, just remember we don't do 3 times 3 first. We do our exponents first. So I would do 3 to the 9th, and I would get 3 times 19,683. And then I would multiply by 3 as my last step. So the 10th term is 59,049. So I'm able to jump to that value by using the formula. In number 8, they want us to again find a sub 10. So I'm going to replace n with 10. And then it's going to be negative 4 times negative 5 to the 10 minus 1. So a sub 10 would be equal to negative 4 times negative 5 to the 9th power. Now, when we do this one, again, you can type the entire thing in the calculator. That includes the parentheses, remember, because here that really does make a difference, especially if we have an even exponent. So just be very careful. A sub 10 is going to be equal to negative 4. And then when I do negative 5 to the 9th power with parentheses around that base when I type it in, I would get negative 1,953,125. And so then I have my final answer when I do negative 4 times that. I should have 7,812,500. So that is the 10th term of that sequence in number 8. Now again, like in the past, sometimes we'll be able or we'll be asked to determine the formula ourselves. So the directions for 9 and 10 are to determine the formula for the nth term. So looking at number 9, they give us 8, 12, 18. In order to write the formula, we want to follow the format that we have up here. So that would be a sub n equals a sub 1 times r to the n minus 1. So the two things I need to find are the common ratio and the first term. The first term I can tell quickly is 8. The common ratio I'm going to take by taking a term and putting over what came before. So that would be 12 over 8. So if I do 12 over 8, that reduces to 3 halves. So now I have what I need to write my formula. A sub n stays a sub n. I'm only replacing a sub 1 with 8. The common ratio I found as r is going to go 3 halves in parentheses. And then that will be to the n minus 1, which should stay n minus 1. So you just wrote the formula that would allow you to find any term in the sequence. In number 10, it says the first term of a geometric sequence is 1, and the common ratio is 5. So picking that right out from the problem, a sub 1 is 1, r is 5. We are following the format of the formula on the formula sheet. A sub n equals a sub 1 times r to the n minus 1. And I'm going to replace a sub n stays. A sub 1 gets replaced with 1. Common ratio is 5. And then n minus 1 is the exponent. So obviously you do not need to write the 1 in front. You could just write this as a sub n equals 5 to the n minus 1. Okay, let's move on to our last set of examples. The directions here say determine the common ratio given non-consecutive terms. So that's what makes our final ones a little bit more challenging. We're not going to have 2 terms in a row. So in number 11, the first term in a sequence is 54. So a sub 1 is equal to 54. And the fifth term, so a sub 5, is equal to 2/3. I want to know what is the common ratio. I don't know r. So I'm going to start with my generic formula. a sub n equals a sub 1 times r to the n minus 1. And we're going to use our fifth term as our a sub n. So a sub 5, because we were given the fifth term, is equal to a sub 1, which is 54. R staying r, because I don't know what the ratio is. And then I know I used the fifth term, so that little n in the exponent should be 5 minus 1. So the fifth term is 2/3. So I can replace a sub 5 with 2/3. And then this is 54 to the r times r to the fourth. So I want to get the variable alone. In order to do that, I could divide both sides by 54 or multiply by the reciprocal because there's a fraction on the other side. And when I do that, these 54s cancel. And I get r to the fourth equals 1 over 54 times 2/3 is 1 over 81. So now I don't want r to the fourth. I want just plain r. So when r is squared, we take the square root. When r is cubed, we take the cube root. When r is to the fourth, we take the fourth root. So the way you write that is you make the square root symbol, but then you put a little 4 in the outside spot. And then I'll show you on your calculator how you can get the fourth root. So we're going to go to math. And we're going to pick option 5. See how it has a square root symbol with a little n on the outside? That means it's going to allow me to replace it with whatever I want. So I'm going to pick 5, and your cursor will be out in the edge. That's where we will put the 4, so they know we want the fourth root. And then we'll go underneath and type what we're taking the fourth root of. Here we have a fraction. So we want to hit alpha y equals and pick option 1 for our fraction template. And then we're going to do 1 in the numerator and go down and do 81 in the denominator. And then arrow over to the right to get out from underneath that fourth root and hit enter. Now when you first do this, you may get a decimal just like you see I am getting. You're either going to recognize 0.3 repeating as 1/3, or you can change this decimal to a fraction by hitting second y equals, alpha y equals, and picking, if you scroll down, option 4, which changes things back and forth from fraction to decimal. So I'll pick option 4. Let's try that again. We'll do alpha y equals, pick option 4, and hit enter. And it changes it to 1/3 for me. So now we know that 1/3 is equal to r. And then I go back up and see, what were they even asking me for? They only wanted the common ratio, nothing further. So my final answer is r equals 1/3. In number 12, it says, in a geometric sequence, a sub 1 is 27, a sub 4 is 64. Determine a formula this time. So in order to write the formula, I still need the common ratio. So I'll find the common ratio, and then I'll write the formula. So using the generic outline to start, a sub n equals a sub 1 times r to the n minus 1. We have the fourth term. So it would be a sub 4 equals 27 is the first term, r, and then n minus 1, the n value. Remember, we have the fourth term, so n is 4. But I know the fourth term, so I'm going to replace a sub 4 with 64 equals 27 times r to the third. So I need to get r to the third alone. I'll do that by dividing both sides by 27. So I get r cubed. 64 over 27, I'm going to leave since I know I'm going to be taking the cube root eventually. So I'm going to leave that, and then to undo cubing something, I need to take the cube root. And I'll again remind you of how to do that on your calculator. We are going to find the cube root this time. So we're going to hit math. And we can pick option 4. It already has cube root. The 3's already out there. We're going to do alpha y equals to get our fraction template, option 1, 64 in the numerator, and 27 in the denominator. Arrow out from underneath and hit enter. Once again, we get a decimal, so we can change that to a fraction, because we do not want to write a repeating decimal as our answer, by doing alpha y equals, and remember we're picking option 4 to convert it. So I get 4/3. So I have 4/3 equals R. Now, I needed to find R because the question's asking me to determine the formula. So now I know it's A sub n equals the first term, which is 27, the ratio, which is 4/3, and then to the n minus 1. So to finish, I would like you to try the closure question. It says, consider the pattern of squares below, which you will see here. And then it says, which type of model, arithmetic or geometric, should be used to determine how many squares are in the nth pattern? Explain your answer. And then B, find an equation to model this pattern. So at this time, please pause the video, try the closure question on your own, and then resume the video to go over your answers. So here are the answers to your closure question. Counting the blocks, you have 2, 4, 8. So that's the start of your sequence. So when I try to see if it's arithmetic, 2 plus 2 would be 4, but then if I were to add 2 again, I would get 6, not 8. So it's not arithmetic. When I do 4 over 2, I get 2. When I do 8 over 4, I get 2. So that means there is a common ratio of 2. So this is geometric because there is not a common difference, but a common ratio of 2. And then once I know that, I can find the equation. A sub 1 is 2, R is 2, and I use the formula. A sub n equals A sub 1 times R to the n minus 1. I will replace A sub 1 with 2 and the ratio with 2, and I have a formula for this pattern. This will allow me to find any term in the sequence. And that concludes your lesson on geometric sequences.